Beyond graphing and analyzing functions, Desmos is also incredibly powerful in helping us analyze data. Data can be tested and displayed in many different ways on the SATs. We could be asked for mean, medians. We'd be asked about standard deviation and compare means and medians between different data sets. The cool thing about Desmos is that we can input all of our data in as lists, and we don't necessarily have to arrange it in any other way than it's been given. So over here, for example, I have created data set A, 1, 8, 9, as long as everything's separated by commas. And we can analyze this data set now for many different things. You can see in the functions, we have mean, median, we can find the min, standard deviation, and of course you could type these all out as well, right? If we wanted the mean of data set A, that's 6.5 something. The median, and you just type that all in and you can find that. Notice we've found the median is 8, which is the second item on this list, even though we haven't sorted A from least to greatest. We can find a couple of different statistics using stats. That gets us our min, our first quartile, median, third quartile, and max. So it gives us the median as well. We could calculate the range really quickly by subtracting the max and the min. And again, notice that we didn't have to rearrange anything for it to just find that max and min for us. And if we wanted to compare standard deviations, we'll just calculate it for any set, type in STDEV. Now, how does this help us on the SAT? So again, several different ways data can be displayed. We have tables, we have lists, dot plots, among many others, but let's start with these for now. So let's say we have a table. We can just turn a table directly into a list in Desmos, and that's what I've done over here, just to save us some time. So we've created set A. And set A is basically everything taken from this table over here, right? You could see we have the snowfall in 2002, 2003, right? 114.9, 129.6. And notice it says for 9 years, and Desmos does keep track of how many items are in your list, right? So over here, it says we have a 9-element list. That's perfect. So let's go ahead and see what happens when we try to solve this question, which is asking for the median in Toronto for all those years. So I could just quickly type in median for set A. That's 114.9, and let's go back. 114.9 is answer choice B. Now, of course, they could just give us a list. That's just the most direct and straightforward, right? What is the mean of the data? So if we wanted the mean of, and I've included all that in set B already to save us some time, mean of B is just going to be 5.1 over here. And we have dot plots as well. So this gets a little bit more complex. How we read a dot plot, each dot represents one value. So over here, for example, 38 appears twice, 39 appears once, 42, 43, 44, 45, we don't see any dots. Those aren't in our set. So you can see it should be 38, 38, 39, 40, 40, 40, so on and so forth, right? So that's 38, 38, 39, 40, 40, 40. We got two 41s and a 46. So it says the value of 46 is removed to create a new data set of 8 values with a mean of y and a median value of z. So what compares the median value, the mean values and the median values for the two data sets? So what we could do over here is find the mean of C and the median of C. So that's 40.333 and 40. And then what we can do is just create the same set, and notice we can just copy and paste just to save us some time. Just eliminate this 46 over here and find the mean of the new set, which is 39, so it's gone down a little bit, and the median of the new set, which is 40. So it's actually the same as it was before we removed that item. And when we're being tested on means and medians, remember the mean is usually affected by extremes. The median is not necessarily, right? So the medians are going to be equal, but the mean is going to go down. And again, they could give this to us in lists as well, right? If we've got 52, 53, 54, 55, 56, and a 7th child with a height of 60 inches is added, what's going to happen, right? And we're being asked about the mean and median again. So I've included this over here. That's our original set. and we care about what happens to the mean and the median. So the mean is median of A. So the mean is currently 54 and the median is also 54. So the question asks what happens if we add a 7th child with a height of 60. And we can just directly change set A as well. So that's 60. And you see the median is still 54, but the mean has gone to 54.85 something, right? So again, the mean has gone up because we've added an extreme, but the median doesn't necessarily change. And we could also use sliders to find and test values that make something true. So we have Aditi and Bella, which works out because I've been using A and B as our lists. Attempted long jumps 5 times, and here are the distances. The mean distance for Bella's attempt was 0.3 meters greater than the mean for Aditi's attempt. What is the value of X? So I've already included A, right? That's Aditi over there, 4.2, 3.8, and 4 and 4.3, and I found the mean. That's going to be 3.9. It says the mean distance for Bella's attempts was 0.3 meters greater than Aditi's. So we basically want a mean of 4.2, which is 3.9 plus 0.3. And if we wanted to just do that real quick, so we had it 3.9 plus 0.3, so we knew what we were looking for. And then we have Bella. So Bella has her jumps, right? So that's 4.4, 3.7, 3.8, 4.6. And then there's X. Remember, X is a reserved value. We can't use it to test a slider in the Desmos app. So I'm just going to use B, and we're going to use a slider there. So this would be if B equals 1, and then we have the mean of set B, which would be 3.5. So we want to move this slider until we get a mean of 4.2, which would be 0.3 higher than Aditi's long jump. And we see we're getting there. B equals 4.5, right? So if that last jump is 4.5, then we end up with a mean of 4.2, which is 0.3 higher than Aditi's. One last note as it pertains to data, we can't quite test our input frequency tables perfectly on the SAT using Desmos yet. Just want to make sure that we understand how these work. It's kind of similar to a dot plot. So the frequency represents the number of dots. In this case, that means the value 0 appears 3 times. So if we wanted to include this as a list, it would be 0, 0, 0, and then 1 3 times. 1, 1, 1, 2, 2, 2, 3, 3, 3, etc. Same deal on this side, right? So that'd be 46, 47, 47, 48, 48, 48, 48, so on and so forth. Can't quite enter them in perfectly into Desmos without just listing it all out and understanding how to really pick apart a frequency table and interpret it. So I wanted to make sure that I took a second to cover that.